The profound quietude of the night sky has been a persistent source of unease for me, stretching back as far as my memory extends. Upon gazing skyward, you are met with the sight of countless stars, a vast celestial tapestry. And that innate intuition, the primal gut feeling that guides your everyday actions, like navigating traffic or catching a ball, insistently suggests that somewhere in the vast expanse, another consciousness must surely be observing us in return. The very thought of our singular existence in the universe feels utterly inconceivable, defying our deepest expectations. However, a critical issue arises when relying solely on these subjective feelings. These primal instincts evolved to facilitate your survival within the confines of the ancient African savanna, not to unravel the intricate, grand structure of the cosmos itself. When one attempts to project that human intuition onto the immense, unfathomable scale of the universe, it doesn't merely prove inadequate, it utterly shatters, completely overwhelmed and crushed by the sheer magnitude. Because the very instant you genuinely examine the underlying mathematics, the raw, unyielding physics that dictate the true nature of time, energy, and distance, you are compelled to confront a profoundly terrifying question. What rational basis do we possess for assuming our subjective gut feelings can exert any authority or influence over the immutable fundamental laws of nature? Observe, on our home planet, Earth, the act of desiring to reach a destination simply translates into direct movement. To achieve greater velocity, one merely applies increased effort or force. However, in the immense expanse beyond our terrestrial sphere, the fundamental rules governing existence undergo a profound and absolute transformation. The cosmos itself has erected 5 distinct, unyielding decrees, 5 absolute impenetrable barriers that fundamentally preclude any civilization from ever achieving an interstellar encounter. And I must be entirely candid with you, these are not simply challenges or hurdles to be overcome. They represent definitive, inescapable cul-de-sacs, absolute points of no return. By the conclusion of our discussion today, you may well experience a profound sense of insignificance, feeling more diminished than ever before. Yet concurrently, you will gain a precise and undeniable understanding of why no one has arrived to save us, and indeed, why no one ever will. Let us now divest ourselves of the fanciful narratives and speculative concepts often found in science fiction. Let us also cast aside the idealized, often unrealistic visions and cinematic illusions propagated by Hollywood. Instead, let us confront the universe in its unvarnished, objective reality as dictated by scientific understanding. The inaugural decree, the very first verdict that utterly confounds our comprehension and challenges our preconceptions even before we embark on any journey, is the sheer, overwhelming immensity of distance. We utter the term space with a certain nonchalance, yet we fundamentally fail to truly grasp its profound implications and the staggering reality it represents. Our biological design inherently limits our capacity to truly grasp the immense figures we are about to explore. Your cognitive architecture is primarily configured to process distances you can traverse by walking or driving. Perhaps only through extensive global travel can one begin to truly conceptualize the immense span of a flight from London to Sydney. That, however, marks the very boundary of our intuitive comprehension. Let us then endeavour to transcend this inherent cognitive barrier. We shall now embark on an ascent through the vast hierarchy of cosmic dimensions. Our journey of scale commences with our home planet Earth. This terrestrial sphere, our planetary home, spans in diameter. From our human perspective, it encompasses an entire world of experience and existence. Yet, within the grand, unfathomable expanse of the universe, it registers as nothing more than a minuscule speck of dust. A complete circumnavigation of its entirety can be accomplished in less than 2 days. Its dimensions, therefore, remain entirely within a comprehensible and manageable scale. Now, let us significantly broaden our perspective. Our life-giving star, the Sun, is situated at an astonishing distance of 150 million kilometres. Even light, the swiftest messenger in the known cosmos, requires more than 8 minutes to traverse that immense void. Were the Sun to instantaneously vanish this very moment, its absence would remain imperceptible to us for another 8 minutes, allowing you to enjoy a sunny afternoon before darkness abruptly enveloped the world. This particular spatial separation, though undeniably vast, can still be conceptually quantified in terms of a relatable temporal duration. However, let us now advance to the subsequent tier of scale, the closest star, not some distant galaxy, but merely our immediate stellar neighbour, Proxima Centauri. This celestial body is situated at a staggering distance of 424 light-years. At this juncture, your innate intuition might mistakenly perceive 424 as a relatively modest numerical value. My capacity extends to 4 distinct units. However, let's contextualize this for a more relatable human understanding. The Parker Solar Probe stands as the swiftest artifact ever engineered by humankind. This craft hurtles through the cosmic void at an astonishing velocity of approximately 692,000 kilometers per hour. To illustrate its incredible pace, one could traverse the distance from New York to Tokyo in less than 60 seconds. Its speed is truly beyond the grasp of human imagination. Were you to embark on a journey aboard that probe, setting a course for Proxima Centauri, our closest stellar neighbour, what duration would such a voyage entail? Would it be a mere month, perhaps a year? The answer, surprisingly, is neither. The actual travel time would extend to a staggering 6,600 years. And this immense duration is merely to reach our immediate stellar vicinity. To truly grasp this scale, imagine departing Earth precisely when the Great Pyramids were completed, maintaining humanity's peak velocity. Your arrival at Proxima Centauri would be occurring only at this very moment. Yet, despite this vast journey, we are speaking of our very next-door celestial neighbour. Now let us broaden our perspective and consider an even grander scale. Our own galactic home, the Milky Way, can be envisioned as our sprawling cosmic metropolis. This colossal structure boasts an immense diameter spanning 100,000 light-years. Attempting to traverse this entire galaxy at the Parker Solar Probe's velocity would demand a journey spanning hundreds of millions of years. This timeframe significantly surpasses the entire evolutionary development of all mammals on Earth. Indeed, one would undergo profound evolutionary changes, potentially becoming a distinct species, long before reaching even the midpoint of such a voyage. Before we delve too profoundly into these vast, almost existential considerations, I'd like to request a small favour. We are poised to explore significantly more profound and complex concepts, such as the fundamental reasons why time travel remains an impossibility, and the fundamental reasons why human physiology struggles within the cosmic void. Should you wish to continue delving into the most profound mysteries of physics alongside me, please consider pressing the like button. This action signals to the algorithm your preference for verifiable reality over convenient falsehoods. Furthermore, it enables me to persist in producing these in-depth explorations. All right, we've already confirmed the immense scale of the cosmos. However, you might be pondering, what is the practical implication of this? Our only requirement, it seems, is to achieve greater velocities. This line of reasoning leads us directly to the second, and arguably most unforgiving decree, the immutable speed of light. The majority of individuals perceive the speed of light, approximately 300,000 kilometers per second, as merely a technological hurdle, akin to the sound barrier. Historically, humanity once believed that supersonic flight was an impossibility. Subsequently, through the development of superior propulsion systems, we successfully surpassed that limit. Therefore, it seems logical to assume that merely a more advanced engine is required to overcome the light speed constraint, correct? Incorrect. The velocity of light does not represent a mere engineering constraint. Instead, it constitutes a fundamental structural boundary inherent to reality itself. More precisely, it defines the ultimate speed at which cause and effect can propagate. This represents the absolute highest velocity at which any occurrence in one location can exert influence upon an occurrence in another. Now consider this common misconception. Within our everyday experience, applying force to an automobile results in its acceleration. Should you exert double the force, its rate of acceleration will likewise double. This represents a straightforward, linear mode of thought. However, upon nearing the velocity of light, the principles of physics cease to operate in a linear fashion. Instead, its behaviour transitions to an asymptotic curve. When an object is propelled with increasing velocity, its kinetic energy correspondingly increases. Yet as one approaches this universal velocity ceiling, an extraordinary phenomenon occurs. The energy imparted to the vessel no longer accelerates it, but rather contributes to an increase in its effective relativistic mass, making it heavier. Consequently, the greater the force applied, the more significant the universe's resistive counterforce becomes. Achieving 100% of light speed for any spaceship possessing mass demands far more than merely a substantial amount of energy. In fact, it necessitates an infinite supply of energy. This isn't merely referring to the total energy contained within our sun. My assertion is that it is, quite literally, boundless. The cumulative energy present across the entirety of the observable cosmos is insufficient to propel even a solitary grain of sand to light speed. This phenomenon acts as an insurmountable vertical barrier. One might achieve velocities of 90%, perhaps 99%, or even 99.9999% of light speed, though this would consume fuel equivalent to an entire galaxy. Nevertheless, that ultimate threshold will remain forever unattainable. Therefore, when individuals inquire why extraterrestrial beings do not simply arrive here more swiftly, the explanation is straightforward. It is due to their inherent inability, Their classification as a Type 3 civilization capable of harnessing the energy of black holes is irrelevant, for they too are bound by the identical universal laws that govern our existence. Even they remain subject to Einstein's fundamental principles. Consequently, this presents an overwhelming practical challenge for any interstellar voyage. Let us assume, for argument's sake, that one concedes to this cosmic velocity ceiling. One might then resolve to journey at a mere 10% of light's ultimate speed. While such a pace is considered glacial by cosmic standards, it represents an astonishing velocity for humanity. This brings us to the third critical impediment, the immense energy demands and the relentless dominion of the rocket equation. This specific challenge, above all others, truly extinguishes the aspiration. The crux of the matter is not philosophical contemplation. Instead, it boils down to the sheer capacity of the fuel reservoir. The foundational rocket equation was meticulously formulated by Konstantin Tsiolkovsky in 1903. Though its name may seem unassuming, it stands as arguably the most unforgiving mathematical expression ever conceived. Its fundamental dictate is clear. Propelling a vessel necessitates a supply of propellant, yet this very propellant inherently possesses mass. Consequently, to transport the initial fuel required for the ship's propulsion, an even greater quantity of fuel becomes necessary. However, this supplementary propellant too contributes its own substantial mass. This creates a cascading demand, requiring still more fuel simply to transport the additional fuel that was needed to move the original propellant. This phenomenon rapidly escalates into an exponential, self-defeating burden. To better grasp this, let us consider a tangible, practical illustration. Picture, if you will, the endeavour of dispatching a spacecraft towards the nearest stellar neighbour. Furthermore, the objective is to accomplish this journey within a single human lifespan, perhaps around 40 years. To embark on such a journey, one must attain a considerable fraction of light's velocity. Yet a critical, often overlooked step follows: the necessity of coming to a complete stop. Upon arrival at your destination, a controlled deceleration is absolutely essential. This implies the necessity of transporting all the fuel required for the braking maneuver across the entire galactic distance, continuously accelerating its mass throughout the voyage. Performing the calculations with our most advanced chemical rocket technology reveals a staggering truth. The fuel mass required to accelerate a single human to Proxima Centauri within a practical time frame would actually exceed the total mass of the entire observable universe. All right, let's consider a technological upgrade. Let's envision utilizing nuclear fusion as our propulsion method. Although this technology is not yet a reality, let's proceed with this hypothetical scenario. Even with the theoretical efficiency of fusion, propelling a small spacecraft to a nearby star would still require the vessel to be almost entirely comprised of fuel. This scenario depicts a colossal flying fuel tank equivalent in size to the Empire State Building, solely to deliver a payload no larger than a toaster. What then about the potential of antimatter? It's frequently hailed as the ultimate, most coveted solution, isn't it? Antimatter, without question, stands as the most extraordinarily potent energy source known to exist. A mere single gram possesses the destructive capability to level an entire city. Yet here lies the critical challenge. Currently, we synthesize antimatter in particle accelerators, painstakingly creating it atom by atom. The cost to produce just a few nanograms of antimatter runs into billions of dollars. To produce enough antimatter to power a starship, humanity would be compelled to dedicate its entire energy output for millions of years solely to fill the fuel tank a single time. It's vital to remember that the universe fundamentally operates on a principle of cost-benefit analysis. Even a civilization advanced enough to harness the energy of an entire star, a Type 2 or Dyson sphere-level civilization, would still possess the mathematical acumen to grasp these profound limitations. Considering the immense energy expenditure required to dispatch either an organic being or an automated probe across 10,000 light-years to a remote exoplanet, advanced intelligences would inevitably conclude such an endeavour represents an egregious squandering of precious resources. What justification exists for expending the equivalent energy of an entire star to journey to a potentially unremarkable world when that very same power could be harnessed to construct an idyllic virtual realm within one's immediate vicinity? Beyond mere power, a hallmark of truly advanced civilizations is their profound commitment to efficiency. Consequently, traversing the vast distances between stars stands as the quintessential example of inefficiency. Yet, for argument's sake, let us postulate their inherent obstinacy. Imagine they possess boundless resources and choose to disregard the fundamental principles of efficiency. Despite these considerations, the vessel is launched. At this juncture, they confront the fourth critical challenge, the inherent limitations of biology. While we often romanticize the image of humans gracefully navigating space in sleek suits, the reality is that human physiology is remarkably delicate and demanding. Our biological design is meticulously tailored for a singular, specific environment. Earth, this includes Earth's familiar 1G gravitational pull, its protective atmospheric pressure, and its vital magnetic field shielding. In stark contrast, the cosmos beyond our planet is an unforgiving, intensely radioactive environment. The instant one departs the protective embrace of Earth's magnetosphere, an incessant barrage of cosmic rays begins. These are not merely photons of light, rather they are high-velocity subatomic projectiles, protons and heavy ions accelerating to near the speed of light. Their destructive power extends beyond superficial impact. These particles rip through spacecraft hulls, penetrate living tissue, and shatter DNA into fragments akin to a shotgun blast, devastating a library. Even a relatively short journey to Mars would dramatically elevate one's lifetime risk of developing cancer. Embarking on an interstellar voyage, however, would ensure mortality long before even traversing the orbit of Pluto. To mitigate this, protective shielding several meters thick and composed of dense materials like lead, water, or concrete would be absolutely indispensable. However, do you recall the fundamental principles of the rocket equation? The critical implication is that such extensive shielding adds an immense amount of mass. Increased mass necessitates a greater expenditure of propellant. A larger fuel supply directly contributes to an overall increase in the vehicle's total weight. We find ourselves once more ensnared in this inescapable detrimental feedback loop. No. The existential threats are not limited to radiation exposure. The profound effects of microgravity are equally perilous. In the absence of gravitational forces, your skeletal structure undergoes significant demineralization and weakening. Your cardiac muscle atrophies and becomes less efficient due to the diminished workload in a zero-gravity environment. Ocular structures undergo significant and potentially permanent morphological changes. After merely 6 months aboard the International Space Station, astronauts return to Earth with considerable physiological impairments. Envision the sheer scale and duration of an interstellar voyage spanning 6 centuries. You might propose, why not simply place them in a state of suspended animation or cryosleep? However, when a living cell is frozen, the intracellular water forms sharp ice crystals, effectively puncturing and destroying the delicate cell membranes. Humanity currently lacks the scientific understanding and technological capability to cryogenically preserve an individual without causing catastrophic cellular destruction. Perhaps you're contemplating the concept of multi-generational starships. The plan would involve successive generations living out their entire lives aboard the vessel, with only their distant descendants ultimately completing the journey. Are you truly familiar with the inherent complexities and frailties of human nature? Imagine confining 500 individuals within a sealed metallic vessel for half a millennium. Within such isolation, established societal frameworks would inevitably disintegrate, linguistic evolution would accelerate, and the prevalence of genetic anomalies from consanguinity would dramatically escalate. By the time they finally reach their destination, the original purpose of their ancestral exodus will be long forgotten, and their capacity for diplomatic engagement will be severely compromised. Terrestrial biology, akin to Earth's native operating system, is fundamentally incompatible with the alien hardware and harsh conditions of the cosmos. However, what if these extraterrestrial intelligences are not organic life forms, but rather advanced artificial intelligences or autonomous robotic entities? Silicon, unlike biological organisms, is not susceptible to diseases like cancer, is it? That's correct, however. Silicon is equally vulnerable to radiation. High-energy particles can induce bit flips within computer memory, thereby corrupting vital data. Across countless millennia in the harsh expanse of deep space, without any possibility of hardware maintenance or repair, the relentless march of entropy inevitably takes its toll. Electronic circuitry will inevitably deteriorate, and structural metals will succumb to material fatigue. Even minuscule micrometeoroids, mere dust grains in size, can impact a vessel with the destructive force of a hand grenade, a direct consequence of their extreme relative velocities. Ultimately, even the most advanced machinery possesses a finite operational lifespan, and the vastness of the galaxy far exceeds the scope of any earthly warranty. We now turn to the fifth and ultimate explanation, the one that most profoundly elucidates the pervasive cosmic silence, the intricate interplay of information exchange and the immense stretches of time. Let us hypothesize a civilization that has successfully conquered the challenges of interstellar distance, energy acquisition, and biological constraints. If such advanced entities truly exist, then why have they not yet made contact? The fundamental issue is that the cosmos itself functions as an incredibly inefficient communication network. Humanity, for its part, has only been actively broadcasting radio signals for roughly a century. Consequently, our technological footprint has expanded outwards, creating a detectable radiosphere around Earth, which now spans approximately 100 light-years in diameter. Within the colossal expanse of the Milky Way galaxy, which stretches an astonishing 100,000 light-years across, our nascent radiosphere appears as nothing more than an infinitesimally small speck. Our collective efforts to communicate are akin to a faint whisper lost within the overwhelming tumult of a cosmic hurricane. For any distant intelligence to successfully intercept our transmissions, an extraordinarily precise alignment of factors is indispensable. They must be observing our specific location at the exact temporal window and tuned to the precise frequency of our broadcasts. Ponder, for a moment, the immense challenge encapsulated by the metaphor of the cosmic haystack. The cosmos teems with billions of stars, each a potential source, and an equally staggering multitude of possible communication frequencies to monitor. Imagine an alien civilization aiming its radio telescope at Earth. If they were to do so in the year 1500 AD, their receivers would detect nothing but profound silence. At that specific historical juncture, humanity had not yet conceived of or developed radio transmission technology. Conversely, if they were to attempt listening today from a distance of 200 light-years, they would still encounter silence, as our radio emissions would not have had sufficient time to bridge that immense cosmic gap. This temporal misalignment directly gives rise to the profound challenge posed by asynchronous civilizations. Across the vast tapestry of cosmic history, civilizations invariably emerge, reach their zenith, and ultimately recede into oblivion. Our species has only embraced advanced technology for approximately 2 centuries. While our civilization might endure for another millennium or perhaps 10 millennia with immense fortune, the cosmos itself boasts an age of 13.8 billion years. The probability of 2 distinct civilizations coexisting simultaneously within the same cosmic vicinity, operating at an equivalent technological stage, is virtually non-existent. This scenario resembles 2 fireflies illuminating briefly within a vast dark forest, yet one emits its light on a Tuesday while the other flashes on a Friday. Consequently, their paths never intersect and they remain unseen by one another. An intelligent species could have thrived on a world orbiting Proxima Centauri a billion years in the past. However, their existence has long since concluded. Conversely, another civilization might emerge in that very location a billion years into the future. By then, our own presence will have vanished. The profound sorrow of the cosmos does not stem from its inherent nature. Rather, it lies in the fact that its inhabitants, like guests at a grand gathering, arrive at vastly disparate moments in time. Therefore, when one synthesizes these 5 critical limitations, mind-boggling distances, a speed barrier defying physical laws, prohibitive energy expenditures, biological constraints on the body, and temporal disconnections, the resulting inference is undeniably severe. Extraterrestrial beings are not arriving, which naturally leads us to address the most obvious yet unacknowledged issue. Nevertheless, what explanation exists for the unidentified flying objects, and what of the documented footage released by the Navy? While I appreciate a compelling enigma, it is imperative that we now apply the principles of physics we have just discussed. We observe visual evidence depicting vehicles accelerating from a standstill to Mach 20 within a single second. Are you aware of the profound effects such extreme acceleration has on matter? It generates immense g-forces. Achieving such rapid acceleration would produce gravitational forces measuring in the thousands of Gs. Under such intense conditions, electronic components would be crushed, metallic structures would melt into liquid, and any biological occupants would instantaneously vaporize into a crimson mist. Despite this, these alleged craft exhibit no interaction with the surrounding atmosphere. There is an absence of any discernible sonic boom or an ionization trail. Any object travelling at such incredible speeds within our atmosphere would inevitably ionize the air molecules, producing an immense plasma wake, a luminous phenomenon akin to a second sun blazing across the sky. Yet none of this is discernible in the available video evidence. What one observes instead is merely an indistinct greyish form. Is it truly more probable that an extraterrestrial civilization has achieved mastery over boundless energy, defied the principles of inertia, nullified sonic booms, journeyed across 10,000 light-years, only to then engage in a game of cat and mouse with a US Navy aircraft, all while being captured by a low-resolution infrared camera? Alternatively, is it not considerably more plausible that we are observing a camera anomaly, a rotating gimbal reflection, an unmanned aerial vehicle, or perhaps a bird viewed through the distortion of parallax? I understand this perspective may seem unexciting and our innate desire to believe is strong, yet it remains a fundamental truth that exceptional assertions demand exceptional proof, and indistinct video recordings simply do not qualify as such. In essence, they constitute nothing beyond ambiguous visual records. Were extraterrestrial beings truly present, possessing the immense energy capacity necessary for interstellar travel, their existence would not hinge upon verification by a low-quality video recording. Their presence would be unequivocally apparent. The sheer physical implications of their arrival would be incontrovertible. However, I gave my word at the outset that this narrative would not conclude on a somber note, and I stand by that assurance. For when we divest ourselves of the fanciful notion of extraterrestrials arriving either to rescue or annihilate us, what remains is a truth of significantly greater depth. We are compelled to confront the cosmos in its authentic state, and realm governed by immutable laws and inherent order. Reflect upon this point. Were the speed of light not an absolute cosmic constant, the very fabric of causality would unravel. Consequences could manifest prior to their antecedent causes. The cosmos would devolve into an utterly chaotic disarray, rendering the very concept of a coherent history impossible. Paradoxically, the very principles that confine us to this existence are precisely those that enable stars to sustain their steady fusion, atoms to maintain their integrity, and life itself to emerge and diversify. The vast echoing quietude of the cosmos necessitates our collective maturation. It compels us to grasp the stark reality that no external entity will intervene to rectify our climatic crises, resolve our conflicts, or stabilize our economic systems. Within this vast expanse, we are the singular presence. This delicate azure sphere represents our sole, irreplaceable sanctuary, and there is an inherent splendor in that profound isolation. Such uniqueness bestows upon us an extraordinary value. Were the cosmos bustling with starships traversing its expanse, our Earth would merely be one world among countless others. Yet in a universe defined by its profound silence, Earth stands as an undeniable marvel. Life itself is a statistical improbability, an astonishing occurrence against all odds. We are the universe itself, awakening to observe and comprehend its own existence, and our relentless quest for understanding continues unabated. We are simply refining our methodologies, becoming more astute in our approach. Our focus is now directed towards identifying technosignatures, the hallmarks of advanced civilizations. We are actively searching for the residual heat emissions indicative of colossal Dyson spheres. We are seeking out the distinct patterns of directed laser pulses. We are attentively listening to the distant stars, not with the frantic desperation of a lost child, but with the measured patience characteristic of a dedicated scientist. A direct, physical encounter with an extraterrestrial being may forever elude us. We might never share a casual drink in an interstellar cantina, yet we are bound by the identical laws of physics. We are composed of the very same elements. The carbon within your hand and the carbon in an alien's appendage were forged in the fiery hearts of similar dying stars. Our profound connection stems not from interstellar travel, but from the fundamental, unifying principles of nature itself. Therefore, the next time you gaze upon the night sky and perceive its overwhelming quietude, do not succumb to feelings of loneliness. Instead, embrace a sense of profound pride. Here we stand, in this very moment. We are progressively making sense of it. Our very being is the improbable, almost miraculous consequence of 13.8 billion years of cosmic serendipity. And in this present moment, that realization offers profound sufficiency. We are bound to concede the realities of distance, time, and energy, but we are under no obligation to yield to ignorance. Maintain your gaze towards the heavens. Do not shy away from posing the most profound and challenging questions. Always remember, the universe is under no compulsion to reveal its secrets to us, which consequently makes the act of uncovering them immeasurably more satisfying. To have reached this stage signifies your inclusion in the exclusive 1% who genuinely prioritize and pursue profound truths. If you're keen to join my next exploration, where we'll meticulously unravel the very fabric of existence to understand its operations, then do ensure you've subscribed. Together, we shall persevere in our quest to explore the profound stillness. Until our next shared experience,